So now we are going to start with the effect of pressure on equilibrium. We have seen effect of concentration on equilibrium. Next is effect of pressure on equilibrium. For that I am taking an example. N2 gas plus 3H2 gas in equilibrium with 2NH3 gas. In a particular vessel we have taken one volume of nitrogen. It is mixed with the 3 volume of oxygen, and after reaction we are getting, when equilibrium is attained, we are getting only 2 moles of ammonia. That is 1 plus 3 mole of reacting substances, that is 4 moles are reacting here, and we are getting only 3 moles. So along the forward reaction, the volume is decreasing. In a particular vessel, in a fixed volume, we are doing the reactions, and volume of the gases or quantity of the gas is decreasing, the volume will decrease. The amount of gas inside the chamber will decrease, then pressure will decrease. So in the forward reaction, pressure is decreasing. Pressure is decreasing in the forward reaction. Pressure decreases. Now what about then backward reaction? The pressure is increasing. In the backward reaction, then pressure will increase. So when this reaction is carried out, the total volume of the gas is decreasing in a fixed volume. So the quantity of gas is decreasing. So since the quantity of gas is decreasing, the amount of the gas inside the chamber is decreasing. Therefore, the pressure also will decrease. So in the forward reaction, pressure is decreasing. That means in the backward reaction, pressure is increasing. Suppose we apply a high pressure at the equilibrium. When the equilibrium is reached, we apply a high pressure. What will happen? The system will try to decrease the effect of high pressure by shifting the equilibrium. To which direction it will split? In the forward reaction, if the forward reaction is carried out, then the pressure will decrease. So we applied a high pressure. To decrease its effect, the pressure has to decrease, isn't it? So how the pressure will decrease if you do the forward reaction? So if you apply a high pressure, more forward reaction will take place, so that the effect of increase in pressure can be nullified. If you decrease the pressure, what will happen? What the system will do to increase the pressure, it will do the backward reaction. Okay, so depending on the volume, depending on the pressure, whether it is increasing or decreasing, the equilibrium will be shifted. So here in the forward reaction, the pressure is decreasing, then in the backward reaction, pressure will increase. So if we are applying a high pressure, the system will try to nullify the effect of pressure by decreasing. It has to decrease the pressure. How to decrease the pressure? If it is carrying out the forward reaction. So more forward reaction will take place. Understood? So a high pressure will favor the forward reaction, and a low pressure will favor the backward reaction. Another example, sulfur dioxide, 2SO2 plus O2 in equilibrium with 2SO3. Here 2 plus 1, 3 moles of gas is reacting, and in the product side we are getting only 2 moles of gases. That means the quantity of gas is decreasing. That means the pressure of the gas is decreasing again in the forward reaction. It decreases, then in the backward reaction it is increasing. So if you apply a high pressure, the forward reaction will be favored, and if you apply a low pressure, the backward reaction will be favored. So this is the effect of pressure on equilibrium. Now we will go to the effect of temperature. Again I will take this example, that is N2 gas plus 3H2 gas. This is delta H is equal to minus 92.4 kilojoule per mole. That means the forward reaction is exothermic. That means heat is evolved. So the forward reaction is exothermic. Then the backward reaction will be endothermic. So forward reaction is exothermic and the backward reaction is endothermic. Endothermic. That means forward reaction, heat energy will be evolved, and in the backward reaction, the heat energy will be absorbed. Now, suppose we are increasing the temperature. We are increasing the temperature. The system will have to nullify this effect of increased temperature. What will it have to do? It will have to nullify the effect. How to nullify the effect? By absorbing the excess heat. So it will absorb the excess heat. In which direction then the reaction will go? Here the backward reaction is endothermic. So the backward reaction will take place where the heat is absorbed. So if you apply a high temperature, the backward reaction will be favored because in the backward reaction energy is absorbed. Suppose a low temperature, suppose you are applying only a low temperature, then what will happen? To increase the temperature, the heat energy must be evolved. So how to evolve the heat energy? The forward reaction. Understood? So a high temperature will favor the backward reaction and the low temperature will favor the forward reaction. So this is the effect of temperature in this equilibrium. In different equilibrium it will be different. If the forward reaction is exothermic and backward reaction is endothermic, that means here it is given minus 92.4 means it is exothermic. Anywhere the energy change of the forward reaction will be given. Here it is given minus 92.4. That means the forward reaction has an enthalpy change of minus 92.4. That means it is exothermic. Then if the forward reaction is exothermic, then the backward reaction will be endothermic. So here the backward reaction is endothermic, and if you apply a high temperature, then the system will have to absorb the excess of energy supplied. So it will favor the backward reaction which energy is absorbed. So a high temperature will favor such a reaction, the backward reaction of such a equilibrium. Okay. Suppose you apply a very low temperature, the temperature is decreased, then the system will have to nullify the decrease in temperature by liberating the heat. How? The forward reaction, if it is carried out, the heat will be liberated. So if the forward reaction is exothermic, and then a low temperature will favor the forward reaction. So for such reactions, if the forward reaction is exothermic, a low temperature will favor the forward reaction, whereas a high temperature will favor only the backward reaction. But if the forward reaction is endothermic and backward reaction is exothermic, then a high temperature will favor the forward reaction and a low temperature will favor the backward reaction. Okay, so this is the effect of temperature. Now here in a particular equilibrium, nitrogen and hydrogen reacts with ammonia, we have seen. If you apply, what about the concentration, if quantity of or concentration of reactants, if you increase, it will favor the forward reaction. If you decrease the concentration of the product, then also the forward reaction is favored. That is, you remove ammonia from the reaction site as soon as it is formed. Now, if the what is the effect of pressure? A high pressure will favor the forward reaction because in the forward reaction, the pressure is decreasing. Since the pressure is decreasing, a high pressure will favor the forward reaction. Okay. Now, what about temperature? Since the forward reaction is exothermic and the backward reaction is endothermic, a high temperature will favor the backward reaction, a low temperature will favor the forward reaction. But the problem is, at low temperature, the nitrogen reacts only very slowly because between two nitrogen atoms there is a triple bond and it is very difficult to break the triple bond at a low temperature. Therefore, the reaction will be very slow if the temperature is low. So what they do is they use an optimum temperature in this case. In this case, they use an optimum temperature because nitrogen is chemically inert at a low temperature. Okay, so this is for this particular reaction. I am not talking about all the reactions. I am talking about this reaction because this is a very famous reaction for the industrial process for the manufacturing of ammonia, Haber process. So there we will have to use a moderate temperature so that the rate of reaction of nitrogen becomes fast, because between two nitrogen atoms there is a triple covalent bond. Okay, so this is the effect of pressure, temperature and concentration. Now next factor is catalyst. How the catalyst will affect the rate of a reaction or the equilibrium. Catalyst has no effect on the equilibrium, or it does not have affect the equilibrium constant value. That means equilibrium constant is the molar concentration of the products by molar concentration of the reactant. That means after a particular amount of the reactant is converted to products, then only equilibrium will be attained. The same will happen in presence of catalyst also. But the time taken will be less. That is, equilibrium will be attained at a faster rate. That's all. Equilibrium will be constant, even in presence of a catalyst. There will not be any change. The equilibrium will be attained after all the reactants are converted to products, nothing like that. There is no change in the stage at which equilibrium is reached. But the rate with which equilibrium is reached, or the speed with which equilibrium is reached, will be less if a catalyst is used, because the reaction rate becomes faster. Okay, so catalyst has no effect on equilibrium constant value, because after this much reactants are reacted, equilibrium will be reached. Okay, in that case, in that matter, catalyst has no effect. But it will increase the rate of reaction, then equilibrium will be attained at a faster rate. So these are the factors that affect the equilibrium, and as we said in Le-Chatelier's principle, that if a constraint is applied to a system in equilibrium, that means if a change in all these factors, that is concentration, pressure, temperature, then catalyst, if there is a change in these factors, then the system will try to nullify the effect by shifting the equilibrium right or left. That means if you change the concentration, the pressure, the temperature, etc., then there will be effect on the equilibrium. Okay, this is the factors that affect equilibrium. Now we are going to start with ionic equilibrium. Now what is an ionic equilibrium? An equilibrium which involves the reaction between ions. For example, Fe3 plus ions reacts with the SCN minus ions to form Fe SCN thrice. So this is an ionic equilibrium where the ions are involved. This iron thiocyanate, this is an ionic equilibrium. Here see Fe3 plus ions, thiocyanate ions are reacting to form a blood red colored iron thiocyanate, which is this color, this one. Now here the ions are involved in the reaction. Now certain substances, when you dissolve in water, they completely dissociate, or they dissociate into ions. Such substances are called electrolytes. They are called electrolytes. So electrolytes are substances which dissociate or ionizes in aqueous solution. They are called electrolytes. And electrolytes are of two types: strong electrolytes and and weak electrolytes. Strong and weak electrolytes. Weak. Strong electrolytes are those which completely dissociates in solution. That means, for example, HCl, NaCl, then H2SO4, etc. They are substances which completely dissociate in water. They are called as strong electrolytes. And whereas weak electrolytes are those which dissociate or ionizes to a very less extent. For example, CH3COOH, ethanoic acid, ammonium hydroxide, etc. These are substances which weakly dissociate, or they dissociate only to a very less extent. Now what we are going to study is, we are going to define acid, bases and salts, acid and bases according to the dissociation, etc. Now, there are different definitions for acids, bases and bases. We are going to study the different definitions for acids and bases. First, Arrhenius. This one you have already studied in your 10th class. Arrhenius, acids and bases. How Arrhenius explained acids and bases. Arrhenius said acids are substances which give hydrogen ions in solution. They give hydrogen ions in solution. For example, HCl. It will dissociate to give H plus Cl minus. See, for strong electrolytes, we will put like this because they completely dissociate to corresponding ions. But for weak acids, CH3, COOH, we will put an equilibrium because in weak electrolytes, the ions which are formed after ionization will be in equilibrium with undissociated acid. Only very less extent ionization is there. That means only a small quantity of the molecules are ionized to form ions. So these ions and the undissociated molecules will be in equilibrium. That means at equilibrium the quantity of ethanoic acid dissociates from ethanoate ion and hydrogen ion, and these two combine back to this one. That quantity, that rate will become equal. So this will be in equilibrium with ethanoic acid. Okay. So for strong electrolyte we put a complete equation remark, and for weak electrolytes we put an equilibrium sign. So according to Arrhenius, acids are substances which dissociate or which ionizes in water to give H plus ions. And we have studied that these H plus ions which are produced in water combines with the water molecules to form hydronium ions, HCl plus H2O. Actually what happens is H plus ion will react with the water to form H3O plus Cl minus. CH3 COOH plus H2O will give you CH3 CO minus plus H3O plus. They give hydronium ions in solution. Okay, so these are acids according to Arrhenius. Now bases are substances which give hydroxyl ions in solution. For example, NaOH. NaOH will produce Na plus ions and OH minus ions in solution. Calcium hydroxide. It will be in equilibrium with Ca2 plus 2OH minus. So bases are substances which give hydroxyl ions in solution. These are the definitions given by Arrhenius. Okay, so this is the Arrhenius concept of acids and bases. Now after this comes Lorentz-Bronsted concept. According to Lorentz-Bronsted concept, acids are proton donors and bases are proton acceptors. For example, HCl plus H2O will be H3O plus Cl minus. That means HCl liberates a proton. Proton means H plus ions. Hydrogen atom is having one electron and one proton. If one electron is lost, it becomes only one proton. So hydrogen ions are also called the protons. So this HCl, it donates a proton. So it is an acid. It's an acid. Now, water molecule accepts this proton. So bases are substances which accepts proton. So water molecule is a base. Right? So HCl is an acid since it is donating a proton. Base is a substance which accepts a proton. Here water molecule is accepting a proton. So it is a base. Now, since water molecule accepted a proton, it combines to form a hydronium ion, and HCl, since one proton is donated, it forms Cl minus. Okay. Now, see, the hydronium ion can donate a proton. In the backward reactions, hydronium ion can donate a proton. Since it is donating a proton, it is an acid. It is an acid. So, here you see, water molecule accepts a proton, become hydronium ion. Hydronium ion can donate a proton. Donate a proton, so it's a base. It is the conjugate, so it is a conjugate acid of this base. That is, base is accepting a proton and become an acid. That is the conjugate acid. That acid formed is a conjugate acid of the base H2. It is the conjugate acid of the base. Now, HCl liberated one proton and became Cl minus. Cl minus can accept a proton and become HCl. So, since this is acid, it is called the conjugate base of that acid. Conjugate base of the acid HCl, because Cl minus can accept a proton and become HCl. So HCl is donating a proton, so it is an acid. This can accept a proton, so this is a base. Base of the conjugate base, then it is called. It is the conjugate base of the acid HCl. So H2O is a base, its conjugate acid is H3O plus. HCl is the acid and its conjugate base is Cl minus. Okay. Now I will write H2SO4. H2SO4 plus H2O will become H3O plus HSO4 minus. Now, H2SO4 liberated one proton or donated a proton, so it is the acid. Water accepted a proton, so it is the base. Now, H3O plus can give a proton or release a proton, so it is a acid. That is the conjugate acid of the base. Conjugate acid of the base water, and HSO4 can accept a proton and become H2SO4. So this is the conjugate base. Conjugate base. Okay. Another example. I will write NH3 plus H2O. Here. H2O can, now here H2O is going to donate a proton to NH3. So H2O is the acid. Ammonia is going to accept a proton from water, so it is the base. Since ammonia accepted a proton, then it becomes NH4 plus. NH4 plus. And this can donate a proton to become NH3. So this is the conjugate acid. Then water, since it is donating a proton, it becomes OH minus. It can accept a proton and become H2. So it is the conjugate base. Conjugate base. An acid can form a conjugate base. A base can form a conjugate acid. Okay, so here NH3 is accepting a proton from water, so NH3 is a base. It accepts a proton from water and become NH4 plus, then it is called the conjugate acid of the base NH3. H2O, it is donating a proton, so it is an acid. It donates a proton and become OH minus ion. OH minus can accept a proton, so it is the conjugate base of the acid H2O. Now you will have to see the relationship between acid and its conjugate base, base and its conjugate acid. Acid. First acid is HCl. Its conjugate base is Cl minus. Acid H2SO4. Its conjugate base is HSO4 minus. Then acid H2O. Its conjugate base is OH minus ion. Now I write the base. In the first case, the base is H2O. Its conjugate acid is H3O plus. Base is H2O. There also the conjugate base is H3O plus. Next, NH3 is the base. Its conjugate acid is NH4 plus. Find out the relationship between this. See, between the acid and its conjugate base, there is a difference in proton. HCl, Cl minus, 1 proton less. H2SO4, HSO4, 1 proton less. H2O and OH minus, 1 proton less. Now can you tell me then the conjugate acid, HSO4 minus, its conjugate base? 1 proton less, that means 1 H is also gone, H plus is gone. 1 H plus, when it goes, one more negative charge will come, so it is SO4 2 minus. So HSO4 minus, when it is an acid, its conjugate base is SO4 2 minus, 1 proton less. You take the base H2O, conjugate acid is having 1 proton more. H2O, H3O plus, NH3, NH4 plus. So the base and its conjugate acid. Conjugate acid will have 1 proton more. Now can you tell me NO3 minus. NO3 minus. Its conjugate acid 1 proton more. That means HNO3. It is the conjugate acid. Okay. So this is how we suppose we are asked to write. Write the conjugate base of phosphoric acid, that is H3PO4. The conjugate base of H3PO4. 1 proton less, that means H2PO4. If 1 positive proton goes, it will get a negative charge. So it is H2PO4 minus. Okay, so that's how we will find out the conjugate base of the acid. If you are given base and you find out the conjugate acid, you add 1 more proton. Okay, so HPO4 2 minus. What is the conjugate acid? You add 1 hydrogen. 1 hydrogen, that is H2. H2PO4. If you add 1 proton, then what means 1 negative charge will be less. So it is H2PO4 minus. That is the conjugate acid of the base HPO4 2 minus. Okay, so this is the Lorentz-Bronsted concept. Acid conjugate base concept or base conjugate acid pair. So here acid can act as proton donors, or acids are proton donors and bases are proton acceptors. So HCl plus H2O. HCl donates a proton to water and it becomes Cl minus. So acid is HCl, its conjugate base is Cl minus. Water accepts a proton and it becomes conjugate acid H3O plus. Since it is accepting a proton, it is the base. Its conjugate acid is H3O plus. Ammonia plus H2O. Water is donating a proton. So it is the acid. It donates a proton and becomes OH minus, the conjugate base. NH3, it is accepting a proton, so it is a base. It accepts a proton and becomes NH4 plus, the conjugate acid. So this is the Lorentz-Bronsted concept of acids and bases.